we are going to use Maclaurin series to approximate this integral to 4 digits after the decimal sign. So what we do first is that we recall the Maclaurin series for e to the power u. And remember this, this is what the equation for Maclaurin series for e to the u is. And we know that it converges for all the values of u. So first I have to find Maclaurin series for e to the negative x square over 2. So what we will do is that we will just go ahead and substitute negative x square over 2 in place of u here and find the series expansion. So let's do the substitution. So here, let me make another copy of it so that so here we go. So what we have is that for u, I am going to have negative x square over 2. Okay, so we have the same substitution for u all across the expression. So we have u replaced by this here, the same thing at for this, and let me finish it up for you quickly. Okay, so here we have this, and one moment please. And so there we are. So if we simplify this, what we will get is this. That is, first of all, notice that this amounts to multiplication by negative 1. So I can take it out. And what I can do is I can write it outside here, that it's negative 1 to the power n minus 1, the power that we had before. We can bring this 2 downstairs or in the denominator, and what we will have there is that this is 2 to the n minus 1. So we have this 2 adjusted over there, and then I have this n minus 1 power on x squared, so the exponents will multiply, and I'll take it down in the next step. Okay, so here if you simplify this, what this will become is negative x squared over 2, and continuing the calculation this way, see, negative square will become positive. What we will eventually find is, so when we substitute and write all the values, the expansion will look like this. So what we would like to do here is that we would like to integrate this expression, and this is a convergent power series, so we can integrate it term by term. So the expression is equal to, just I rewrote the same summation. So if I integrate, this integration will be valid. Alright, that means I can integrate it term by term. Alright, I rewrote the same thing, and now I'm applying power rule on this because, see, all these quantities are constants, so I can apply power rule here. So what we are doing is I have x to a constant power, which is different from negative 1, so power rule can be applied. So I got x to the power plus 1 and divided by the same quantity and leaving all these as they are. Okay, so here we go. I just brought this down here, and we will simplify it. It will become 2n minus 1. So what we shall have is finally that the integration of this expression will be this. I'm sorry, I forgot to add a constant, but since we are going to take a definite integral, that arbitrary constant will be taken care of. So here the same expression is rewritten. Okay, and now we are going to do what? We are going to take the definite integral. So now it's erased, and then we needed the definite integral from 0 to 1.28. And so what we will do, we'll just substitute 1.28 here and then substitute 0 there and take the difference, which will become little easy because all these terms will become 0. Okay, so what this comes down to is that this integral is summation of this convergent series. Okay, now of course, I mean, we want to find the value of this integral to the 4 digits after the decimal sign. So what we will do, we will just go ahead and start adding the terms of this convergent series till we obtain our desired level of accuracy. So first let's see how does it look like when we expand this series. So just a moment, yes. So let's see what the first term will look like. So what we will have 1 to negative 1 to the power 1 minus 1. Here we put 1. Then we have 1 here and 1 here and n equals 1 here. So what this quantity will be? See, I'll have negative 1 to the 0, which will be 1. Factorial of 0 is 1, 2 to the 0 is 1, and 2 minus 1 is 1. So this whole term amounts to, sorry about that, what? Here, 1.28 divided by square root of 2 pi, okay? And likewise, when we go to the second term, we will have, we will substitute what? N equals 2 in here and then 2 over here. So we got 2, then 2 in here, 2 over here, and 2 for this. So what do we get here? We get negative 1 to the power 1, which will just give us a negative sign, and 2 times 2 is 4 minus 1 is 3. So I get 1.28 to the power 3 here, and then we have a square root of 2 pi. Factorial of 1 is 1. All right, and then 2 to the 2 minus 1 will simply be 2, and then we will have what? We will have a 3 there. Okay, so if we, I just wanted to show you how an expansion will look like, and here we have the situation that, so the expansion will look like this. Okay, now we will take our calculator and see how to add these terms, until the point that we obtain, that we see the value is stabilized to the 4 digits after the decimal sign. So first what I have done here is that I pressed Y sign here and I have entered this entire expression. Remember, I have posted a video for you for computing the sum sequence. So what we are going to do is that we are just going to add or find the sum of the sequences given by these expressions. Okay, so what do? I mean, we are used to doing that. Let's go to this feature, and how many terms we have here? We have the first 4 terms listed here by taking n from 1 to 4. So here we have sum. So just a second, I don't think I wanted that, excuse me. So sorry about that. What will help here? This helped, and first I should have quit out of it and then go to, okay, so we go to this option first. Okay, so we went to sum, and then we will say that we want the sum of the sequences that are defined by the expression y1. Okay, so here we are, and our expression is y1, and we wrote that in terms of x, and remember x is playing the role of n here, so don't mix them up. Okay, so we will have from 1 to 4. Okay, so these are the first 4 terms that we are adding. All right, so when we set enter, this is what we get. And then so this is what, 0.3987, and if we want to just see what it gives us for the 5 terms, okay, well, it's 0.39985, so it has still not stabilized. So we will look at the sequence further. Okay, so here we go to 6, and what do we get? 0.3997, and then let's see what adding up to 7 terms gives us. This is, so looks like we have achieved the objective here, that to the 4 digits after the decimal sign, the value will be 0.3997. Now, those of you who took a statistics course, remember, so in an applied statistics course, you obtain these values from a table, and that's another way of obtaining it. And actually,